Welcome to Virtual for Real, the Rapid Pipeline podcast. I'm Max, CEO and co-founder at Rapid Pipeline, your host, and with me today is Harald Wuest, CEO and co-founder of Visometry, expert in the field with 20 years of experience in machine learning, and we'll talk about computer vision, AI, and different things related to CAD and digital twins. Harald, welcome.
Thank you, Max. Yes, thank you very much for having me here.
Yeah, excited. And maybe just to start the conversation, what excites you about working with 3D models, CAD, digital twins, computer vision? What are your interests? And maybe you can share a bit about your personal journey from researcher to CEO of a successful 3D tech company.
Yeah, computer graphics have been fascinating for me since my early days at high school. And the generation of graphics was always very interesting, and I did lots of coding and rendering things. Like when I started after my studies at the University of Mannheim at the Fraunhofer Institute for Computer Graphics, I went into augmented reality, and there, of course, you have rendering where you need to visualize 3D graphics, but to place the 3D graphics very precisely into the real world, it's also important to understand the positioning of the camera or the relation of the camera in the real world. And so this is more like a computer vision problem to understand the spatial understanding of the scenery like a camera is observing.
Yeah, thanks. And I think this is really what I find already great about this episode, because we talked a lot about rendering and graphics in the past episodes, but we haven't looked at computer vision. And what your team is doing at Visometry is really bringing all of that together with augmented reality and solving QA, quality assurance for physical products with the help of their CAD models and computer vision. So you have a solution that's called Visometry Twin Studio with a Y. And when I think about QA in manufacturing, the traditional way that I have in mind how it probably was all the time for a couple of decades was you have manufactured something out of metal and it stands on a factory floor, and someone goes around it, has a plan printed out, and there's some measurements, and then it says either, oh yeah, here's a little mistake, or oh yeah, it's fine. It was manufactured per specification. So that's the old way. But how does it look with Visometry's twin solution? How do people do that QA step?
When we created our startup 8 years ago, our first product was the VisionLib SDK, which was an augmented reality tracking engine, like the computer vision algorithms. And we made this available for other augmented reality developers who created their own applications. But this SDK business was also kind of difficult. And therefore, we thought what could be an interesting use case for an end user. And we investigated a bit and thought the quality inspection use case could be very interesting. But this application is addressing end users, quality engineers who are in the need of comparing physical objects in the production process of industries in relation to the virtual 3D models. And yeah, as you mentioned, the many quality engineers who are more old school in the production use classical measurement equipment or other systems to individually measure certain distances between holes or bolts. But with the twin application, it is possible to take the 3D CAD data, use the 3D CAD data in overlay of an iPad, and on the iPad screen, the 3D model is precisely within a pixel accuracy overlaid on the camera image. And then it's very easy to detect the differences between the virtual 3D model and the physical part. And typically, like our customers, they build welding structures for very individual vehicles like agricultural machines or construction machines. So they are all produced in low quantities and also high variations. And therefore, the twin application is very interesting because all you need is to load the 3D CAD data, and then you can look at your welding structures and check if there's any differences between virtual and physical object.
That's really great. So that means instead of walking over the shop floor and then just measuring physically and spending time and comparing with a plan that I've printed out, I can just take the iPad and it has the CAD model loaded, and it will take the camera of the iPad and show me where there are any errors or if the part is assembled correctly, right? So I get a traffic light result.
Yes, at the end, it's still in the responsibility of the operator to make the decision if everything is correct. But we have some assisting functionalities. For example, we use some methods where we compare the shapes of the 3D CAD models in the camera image and match this with the contours in the camera image, and then get some red-green coloring where the 3D model is really matching precisely to the camera image. Or if not, then there are like more red areas which indicate the operator, please have a closer look where there's lots of red clutter in the image. And
Yeah.
because it's very likely that there's something not so correct.
Yeah, like a deviation when they assemble something the wrong way. And it sounds like Twin is robust to this to some extent, right? It can still recognize something that has one part that is a little off, and you'll see that right away.
Yeah, typically there might be any clamps missing, or also holes, like drilling holes in some metal sheets have been drilled on the wrong positions. And of course, if you have a 2D paper plan and compare this with a real model, it's very hard to distinguish if a drilling hole is half a centimeter misplaced. But if you see this in the direct overlay, it's very obvious that there's a hole misplaced by half a centimeter. And this makes it very easy for the quality engineer to detect those errors. And of course, when these parts go into the manufacturing process, and this error is detected very late in the process when the machine or the vehicle is half assembled, then there are high costs for disassembling and doing the rework. And so there's a high interest detecting these errors very early in the process.
Yeah, and it's much faster also than doing a full 3D scan, right? Because that would be an alternative that someone takes a 3D scanner, a modern alternative, and they walk around the product in the workshop and they do a scan, and then they have that at some point on a computer, and then they use a program to compare those. But your approach is way more fast and lightweight because the operator just takes their iPad, walks to the product, and directly sees the result, right?
Yeah, of course, these 3D scanners are also like a valid approach to compare virtual 3D models with physical objects. The benefit of the iPad is, of course, also the price, because typically these 3D scanners are like high expensive metrological devices, but an iPad is, of course, a very cheap consumer device. Also, the fact that these metrological devices have a limited measurement volume, because they are also wired with a high-end computing device to collect all the data for the depth images and the reconstruction of the whole set of depth images. And so this is a limited volume. And with the iPad, we basically don't have any limitations with the size of these objects, because we don't have to accumulate any data on a certain volume. So we can use the iPad solution also on very large objects, like on construction machines, or also buildings. Or we have customers who build train cars, and these train cars or train wagons are like 40 meters long. And it's also possible to walk through these train cars and always check certain issues like clamps or other welding structures. And this is also a big benefit, because with an iPad, you are very mobile and you can do the inspection anywhere you want.
And is that where you also use rapid pipelines? So when you have really large CAD models?
Yes, like the TwinView application on the iPad, we have the intention to make the application as lightweight as possible, and also to put only the necessary 3D data on the iPad mobile device. Still, the iPad, regarding the computing power, it's quite okay, and it's possible to do lots of computing on the iPad device, but still, when the models are getting too large with a couple of hundreds of megabytes, and then, of course, in the loading process, there's also the tessellation. Therefore, in the Twin Studio application, we also use the Rapid Compact to really make the 3D data very compact, and that we can also do the polygon reduction and make the quality of the 3D polygon models just in such a way that they are good enough to fulfill the purpose, but also to save as much space as possible. We also want to have a real-time tracking, so the user shall freely move around the iPad and we get like a frame rate of 30 frames. So we have a very immersive and good experience when we use the application. The models need to be not too complex, and therefore the rapid pipeline is like a very good component in our process of putting the 3D CAD data in such a form that they really perform very well on the iPad app.
Great. Yeah, thank you so much. And it sounds like a complex pipeline indeed, a lot of heavy lifting to make the magic work in the end on the iPads. And so you work with the CAD models, right? That's the reference. And I was just wondering when you spoke about that. So how easy is it for your users to get the CAD models? Are there any siloing issues, permissions, anything that you observe there, or like how sensitive is that data? How easy is it to get it for your users?
Yeah. Nowadays, everything which is built is first designed in any CAD tool. So this was like 20 years ago when I published my first paper for this model target tracking, which was like, I think 2005 at the ISMA conference, that is International Symposium for Mixed and Augmented Reality. So this was 22 years ago already. But nobody was interested so much at that time because everybody was thinking, I need the 3D data I don't have this 3D data. We only have 2D manufacturing plans. And this was not so easy. But today, everything which is built, there is some 3D model somewhere. And so this is not such a big issue anymore because the 3D data is there. Of course, for many manufacturing companies, the 3D data is one of the main assets, and it's also a very sensitive thing, sharing the 3D data for other people. Typically, we always have to sign some NDAs when we do some tests at some customer sites. And then, this also works out. But at the end, because of the sensitivity of many customers about their 3D data, we also try to not send this data anywhere and always keep this on device. So we also don't have any cloud infrastructure so that it's not necessary to have a connection anywhere in the factory shop floor.
Yeah. So you don't even need internet or intranet for it to work.
No, not for the operation. You only if you transfer the data, of course, you need some connection. But if you carry out the comparison between virtual and physical objects, you don't need any network connection.
And I want to just talk a little bit about another topic that, of course, interests everyone these days, which is AI. And I mentioned in the beginning that your team has 20 years of experience working on machine learning. And then for 2 years, I heard you guys are also using deep neural networks. So maybe you can tell us a little bit about where are you using machine learning already for 20 years? What's that area and what does it do in Twin?
Okay, yeah, there was this big hype of deep neural networks with the upcoming large language models, but neural networks have also been around there since the 70s. And we also used lots of classical machine learning and pattern recognition, for example, also for feature detecting, like point-based feature detecting and also feature matching. Or also, for example, we use for reinitializing the tracking, we use dominant orientation templates, which rely on a histogram of gradient orientations. And these are more like very classical pattern recognition and machine learning approaches. But now we also use the deep neural networks for certain things like the validation of certain objects which cannot be used by geometry or cannot be validated by geometry. Some very small objects like bolts or screws or welding spots. Like welding spots don't have any geometry, so it's mostly like a flat surface. And so these things cannot be validated by the typical approach with the geometric information, how we use it. And so therefore we have all other algorithms which are also based on deep neural networks. And with these methods, we are able to detect the existence of certain very small components, like, for example, for like large train cars, there are like hundreds of these bolts, and like the quality operator doesn't want to click a couple of hundred bolts that they're all correct and existing. And with these AI methods, it's more possible taking the iPad and just walking along the wall, and then you get all green flags or red flags on the bolts, and they're like automatically detected if they're existing or if they're existing at the correct position. And therefore we use AI methods for detecting these very small components like welding spots or holes.
That makes sense. And it's super exciting to hear about these cases in practice, like the balls, but even the welding spots, what you mentioned, which, yeah, we don't have them in the CAD model, right? I understand you can detect them with AI, and then you can compare them to something like a list that you would have in addition to the CAD model. So you're basically taking even different data sources and bringing them together and then doing the QA for the whole.
In many cases, they're not represented in the CAD models, and they come later in the manufacturing process where there are different files. For example, the coordinates of the welding spots, which typically go to the welding robots. And these coordinates, they can also be used in the twin application to validate these certain components in the 3D space while walking around with a tablet around these metal structures.
Great. Yeah, makes a lot of sense. And it's really impressive. I'm wondering if we take that as a segue also what has been happening now the past couple of years, projecting forward, where do you see things going, CAD and digital twins as a general trend? So you guys are doing amazing work enabling automation of QA through augmented reality and computer vision. Where do you think the industry will be going maybe in 10 years from now when it comes to CAD and virtual technologies around digital twins?
Yes, so now we use these AI methods for assisting the operator. So for now, the operator is in the responsibility to make all the decisions. But when all these methods getting better and are more reliable, then we can also go from assisting functionalities to fully automation functionalities. And we have also lots of customers who ask us, okay, this is all great, but why do we need some human person holding the iPad? And sometimes there are also crazy ideas of taking a robot holding an iPad and making this inspection. But of course, that this is no purpose having an iPad with a touch screen anymore. Then of course the purpose is more interesting when we fully automate these solutions, like having a camera which is then observing some certain structure, and everything is happening fully automated, like all the existence check and the validation. And of course, this is very challenging because typically there are existing solutions which can be trained for 3 weeks for a certain scenario, but for a very general purpose 3D CAD model comparison with physical objects, you always need some more generic approach. But I guess this could be a possibility in 10 years that all you need to do is load a 3D CAD model into the system and tell the system just validate this object from all sides, and then this could be fully automated with any robot assistance. This, probably takes some time until we get there. On the way to this scenario, we try to put as much as assisting functionalities so that this is like a step-by-step process towards a fully automated solution.
And do you see any potential in the meantime with things like the smart glasses as an alternative to the iPads, or is that not a good option?
Yes, there have been smart glasses around a lot, starting with the HoloLens. The HoloLens was really a very interesting device when it came out, and it was also very hyped. And we also looked at this and ported our Visionlib SDK at the HoloLens. Typically, these glasses always suffer from the daily use, which is more complicated from ergonomic perspectives. And like always, when there are new glasses, also when the Apple Vision Pro came out, everybody was asking us, hey, can we also do this on the Apple Vision Pro? But from our experience, at least for the quality inspection use case, using a tablet is always more useful because pressing buttons on a tablet, everybody understands how to press buttons on a tablet. With these glasses, the interaction is much more complicated.
Definitely.
Especially for the HoloLens with like this air clicking thing, or typing text, it's just a way bigger hassle. The big companies, they're still working on new glasses, like also Meta or Apple or other companies. And so I guess it could be possible that at some point that the glasses are so comfortable that it's not hindering the people in wearing them on a daily basis or everyday use. So this could also be a trend in the next years. But I guess it's slow because the ideas of having glasses for augmented reality have been around for so long, and it's still hard to getting really productive applications out on the factory floors where people use these glasses. So we always recommend people, at least for now, better think of using tablets because they are way more usable devices. But who knows, when we think in 10 years, it might be possible that glasses have a form factor which are so easy to wear and with a long enough battery life that these devices are valuable for the hands-free operation. When you do quality inspection, of course, you can do documentation on the tablets, but when you do assembly, it's valuable to have the hands-free, and therefore the glasses can be, of course, a big benefit. Yeah, it might take some time. Typically, most of the people have higher expectations that this goes way faster, but when we look back at the last 20 years, yeah, the development, especially for the industrial processes, are typically way slower than many people expect.
Thank you so much. I think that's a really great, very refined take, and even sharing some ideas on where glasses might make sense and where not, right? So the hands-free operation versus the usability of the interface and these kind of aspects. So for me, that was really insightful, very interesting. Yeah, I think that's a great outlook. And I'd just like to thank you again, Harald, for sharing all of these thoughts. I would be looking forward to talking more to you. And thanks for having been guest on the podcast today.
Yeah, thank you also very much. It was very interesting. Yeah, thanks again for the opportunity.